one word of warning, sort of from here on out, the carboxylic acid derivatives, their nomenclature is no longer simple. It's not really trivial anymore. You have to really practice it in order to feel confident with it. So make sure you do plenty of problems in the textbook, do that nomenclature worksheet in the Polgo book, check your answers all the time. So let's start with reviewing how carboxylic acids are named, because every carboxylic acid derivative, its name is derived from the carboxylic acid that's related to it. Remember, especially these two common names. Acetic acid is the 2-carbon carboxylic acid, right? CH3C double bond O, OH. Or formic acid is just a 1-carbon carboxylic acid, H, C double bond O, OH. Okay. 3 carbons and beyond, we're typically fine using real IUPAC names like propanoic acid or butanoic or pentanoic or hexanoic. Propanoic acid is the 3-carbon, so CH3CH2, C double bond O, OH. Remember, if you have a carboxylic acid, a C double bond OH, that is off of a ring, right? So if I have cyclohexane carboxylic acid, it looks like this. Here's the cyclohexane, and then attached to one of those carbons is a C double bond O, OH. So calling something cycloalkane carboxylic acid, okay, means we have a C double bond O, OH that's off of a ring. The acid can't be part of a ring, right, since only one additional bond comes from this carbonyl carbon. So it has to be off of the ring like that. Let's start by naming acid halides. An acid halide is where we have R, C double bond O, and some halogen, usually chlorine or bromine. So what we do, we have to look and try to figure out what the original carboxylic acid would have been. So instead of the halogen, if it was OH there, we take that acid name and then replace the ic acid with eel halide. Okay? So YL chloride or YL bromide. So where I had acetic acid up here, I now have acetyl chloride. So benzoic acid, right, is a benzene with C double bond O, OH. So the acid bromide derived from it is benzoyl bromide, right? Benzoic acid, I only took the ic, so there's benzoyl bromide. Look at cyclohexane carboxylic acid. I now have cyclohexane carbonyl chloride. The carboxylic acid becomes carbonyl halide. Okay, so anhydrides are sometimes a little easier to name. We just substitute anhydride for acid if it's symmetrical. So acetic acid becomes acetic anhydride because it's as if you took 2 acetic acid molecules and they share this common O between them. Anhydrides always have C double bond O, O, C double bond O. It's always that pattern. So if you have 2 acetic acids and you removed an H and an OH from them, you get acetic anhydride. So benzoic acid makes benzoic anhydride. This one's kind of interesting. Succinic anhydride, because succinic is the common name for the 1, 2, 3, 4 carbon carboxylic acid, right? HOC double bond O, CH2, CH2, C double bond O, OH. That is succinic acid. So you may need to look up some of the common names of those dicarboxylic acids. I'm not having you memorize those, but you may run into names like that. Those dicarboxylic acids very commonly use their common name. If we have an unsymmetrical anhydride, like if it came from 2 carboxylic acids, we just name it from the 2 acids that it's prepared from and use the 2 names alphabetically. So if I have like acetic acid and benzoic acid that are joined together at that oxygen, I have acetic benzoic anhydride. Amides are when we have C double bond O and N with any number of R groups. Okay? It could be NH2 or 1 R group or 2 R groups. So just starting with the simple NH2 amides, we would again take the carboxylic acid name and replace either oic acid or ic acid. Okay? So if it's an oic acid, we'd take that O with, okay? Because we'd want to avoid that double vowel there. And we just replace it with amide. So acetic acid becomes acetamide. Hexanoic acid becomes hexanamide. See, we took the O as well. It's a little different from the acid chlorides and so on. If we used carboxylic acid, we'll replace it with carboxamide. So if I had cyclopentane carboxylic acid, that would be OH here. Okay, that becomes cyclopentane carboxamide. If we have R groups attached to the N, we just do like we did before, except add those R groups at the beginning, right, calling them N-alkyl. So where that N is, it would be just like calling something, 3-methyl if it was on a carbon chain or something like that. So here's the N-methyl propanamide, right? Propanoic acid is what it was originally. Propanamide would be NH2 here. N-methyl propanamide has one methyl group. And if we have two R groups, we have to call it NN. Right? If they're the same, it's like this NN diethyl cyclohexane carboxamide, because it would have come from cyclohexane carboxylic acid. So the amide, the NH2, would be cyclohexane carboxamide. This is NN diethyl. Okay? We could conceivably have an N-ethyl, N-methyl, something like that. So just add those N-alkyl groups at the beginning of the name. If I have an ester, that's a C double bond O OR functional group. So what we do is identify first the alkyl group that's attached to the oxygen. Okay? That's separate from the carboxylic acid that it originally came from. Right? This one here came from acetic acid. This ethyl group over here was not in the original acid. So this came from acetic acid originally. The ic acid becomes 8 after we identify the alkyl group. So name always starts with this alkyl group. Acetic acid becomes acetate. So ethyl acetate is that one. This is dimethyl malonate because malonic acid is another one of those common names of dicarboxylic acids. You can tell what it is. It's a 3-carbon carboxylic acid. CH2C double bond OH. Right? So if it's a dicarboxylic acid, we do dimethyl. Right? Or if it was mixed, it could be ethyl methyl, right? Something like that. This one, not really much more complicated, but it may seem that way if you're not careful, right? Tert-butyl. So here is the tert-butyl group, right? Remember, we start by identifying the alkyl group attached to the oxygen. So there's tert-butyl cyclohexane carboxylate. The 8 that we have in here is the same as a carboxylate. So it's the same as the conjugate base of a carboxylic acid. So you can just imagine adding an R group to a carboxylate. Right? That's actually one way of making esters. If we started with an IUPAC name from a carboxylic acid, like say for instance the 3-carbon, right? If I had something derived from propanoic acid, right? And let's put a phenyl group there on the other side of the oxygen. Okay? That is phenyl propanoate. We preserve that double vowel with the esters here. I don't know why we do it with the esters and not the amides, but that's the way the IUPAC is. So IUPAC names, right? If it's an oic acid, it becomes an O8